This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 116. We chat with users from ZEVX about how they use Ansys to drive the design of their electric vehicle repower kits and look at the news and events in the world of Ansys. Welcome to our little podcast. My name is Eric Miller, and I'm one of the owners here at PADT. It's the end of March here in Phoenix, and the western U.S. has had one of the wettest years on record. And that means that there is actual water running down the river that is usually a large dirt ditch running east to west across Phoenix. And the best part is the desert is blooming and is truly breathtaking. If such things interest you, put AZ Central, one word, 2023 wildflowers into your favorite search engine and check out the pics from an article in azcentral.com. That's our local newspaper turned into a website that people have taken of the Mexican poppies and other things that are just blooming across the state. It's pretty beautiful. Neat stuff. Anyway, we're here to talk about Ansys. Before we get started, I wanted to share that we've been learning more about the latest Ansys acquisition, CNR Technologies, and their thermal desktop family of products. Fluent is the solver underneath, and it's pretty cool the more we learn. We've known about them for several decades, but getting to know them a little bit better after the acquisition has been really good. And to be honest, we haven't really looked at the code for maybe a couple decades, so really closely. So it's really good stuff. We'll definitely share more when the time is right. But if you do thermal simulation on spacecraft or any complex large system, check it out. Don't wait. It's something you should be, if you're not already using it, you should be looking at now. The more engineers learn about it, the more they like it. So we'll talk about that in an upcoming podcast. But for now, I just wanted to let people know. And before we get into our interview, I wanted to mention that downloads are up on the podcast. So this once a month format seems to be preferred rather than twice a month. And we like the pace as well. So we'll keep it this way. We have over 38,500 downloads of the podcast. That's 115 episodes that goes over. So one thing I did look up while I was poking around in there was what's the average? So the average for podcasts is 140 downloads in the 30 days after it was published. And we're averaging the recent episodes 163 downloads in 30 days. So I'm happy to say that All Things Ansys is above average. So we're nowhere near, I think it was Joe Rogan's, whatever you call, I don't really consider that a podcast. It's really a show, is way up there in the hundreds of thousands. But to make really good money, you got to be like 10,000 or bigger, and it's top 5% or something like that. So we're nowhere near any of those. But for the world of Ansys, we're the only long-standing podcast. So we're happy with our average of 163, and we'll keep it that way for a time. But please do share with others about the podcast if you like it. And don't forget to subscribe if you stumbled upon us through a search engine and want to keep up with what's going on in the world of Ansys. And that brings us to today's interview. We're having interviews are my favorite kind of interviews with customers are my favorite kind of interview that we do. And we're going to talk with two Ansys users. Nitin Chauhan and Chris Dobbs are from a company called ZEVX. And the company's only been around for 3 years, but it's achieved some amazing things. And I will let them explain it to you, what they do and how they use Ansys. And you'll see why I get so jazzed when I learn how they're doing things. Welcome to our discussion today. We are fortunate enough to be joined not only by our very own Doug Oatis from Colorado, but also one of our favorite customers, ZEVX, has agreed to come on and talk a little bit about how they're using simulation with their company. And I am joined by, and my notes are not 100% in front of me, so I apologize, by Chris Dobbs and Nitin Chauhan from ZEVX. Hi, guys.
Hey, how you doing?
Good. Welcome. So let's get started with a real basic of, why don't one of you tell us what ZEVX is and what you guys do?
Yeah, so ZEVX is a worldwide leader in delivering intelligent EV systems powering commercial Class 2 vehicles and all the way through Class 5 vehicles, power takeoffs, refrigerated trailers, and other EV infrastructure such as charging stations. So we do quite a bit here.
That is quite a bit. And how old's the company now?
We are coming up on 3 years, or just hit 3 years, actually last week.
Wow. You guys have done a lot in 3 years. It's one of the reasons why they're one of our favorite customers is because you guys get stuff done. It's pretty cool to watch.
Yeah, we're always busy.
So let's talk about yourselves. Nitin, why don't you start off? Let us know, what your background is, how you got into simulation, and what you do at ZEVX.
Sure. So my background is I have a master's in mechanical engineering, and that's where I first started using Ansys as a product for my some projects, some other projects which I did. Like I used mechanical mostly and some bit of, but that project was mostly like a lot of masters was how actually those equations work rather
Great.
than the application of it. But then yeah, I used Ansys very intensively over here at ZEVX, starting with battery simulations. So ZEVX started doing battery simulations, had a whole project about making modules, battery packs, and other stuff. So we went down to the cell level simulations using the battery models and other stuff in Fluent. So that's how we started. And then later on, we did do mechanical simulations. And then we still use mechanical in Fluent, but Fluent is mostly used for cooling plates. So we make our own battery packs over here at ZEVX. So we design a cooling plates for those. So that's where most of our like Fluent is used, but mechanical is used for now for structural simulations, for vibrations, and even like some like thermal simulations. So those kind of simulations we do here at ZEVX for all our like products, whatever we put in our vehicles. We try to try to simulate those to meet some standards or like vibration standards and some other stuff.
Very cool. Very cool. Yeah, and one kind of subtle point before we hear from Chris that I want to make sure that everybody understands is, and correct me if I'm wrong, what you guys are often doing is retrofitting your powertrain, batteries, motor, drive shaft, all that stuff into an existing vehicle, right? So you don't necessarily know what kind of vehicles these are going to go into all the time, right?
Yeah, correct. So right now, yeah, the main thing we do is we repower existing vehicles with our EV system, / kit. So
Great.
yeah,
Great.
Class 2 vehicles all the way up to Class 5.
Right. So that's a little bit challenging. not always knowing what the environment is. So Chris, why don't you tell us about yourself?
Yeah, I am the Director of Mechanical Engineering here at ZEVX. I do just about of everything. Nitin is our subject matter expert for the simulation side. But yeah, we do it, for all our mechanical structures, vibrations, stress strain, deformation. It's a useful tool.
Very, very cool. Yeah, I'm glad to hear that. So you already talked about what you guys are using Ansys for mostly. So one of the questions I always like to ask is, what is your favorite Ansys product feature? So thinking about, all the different things you guys do, what's the thing you like most about a specific feature in Ansys?
Can I add it? Can I add to that question, Eric?
Yeah, please, Doug.
I also want to know how long it took you to find it. Because that's always kind of a funny one to me, where it's like, some of the awesome tools, like I didn't realize they were there until, I've been using them.
Yeah.
So I'm just kind of curious if we can put a little spice on that.
Yeah, cool.
Yeah, one of the cool features is like I like after so I'm like a like I try to use like design modeler, but then when I found out Space Claim, so Space Claim I didn't even realize that it's such a powerful CAD software. So that's really like it can handle pretty much all kinds of files, like from like mesh files to CAD files to everything, and then it can manipulate it very easily. So that was one of like like you can just manipulate geometry easily. That was one of my biggest things. And then obviously one other feature is like I like Workbench a lot. Like you can do everything in one space. The whole like system level modeling, if you want to say, is like I like Workbench, just how you can put every component system in there at once.
So do you manipulate the STL, like you said, scan data? I don't know if you're working with STLs or are you doing reverse engineering, or are you? I'm kind of curious.
Yes.
All the things that you're manipulating within space.
Yeah, we did do it, and like that's not a like now it's not a like a flow. It's not like that anymore. But I did try doing that for a lot of like let's say like scanned files. So I did try doing that. Just seeing like, hey, can we import an OBJ file in this, because a lot of other CAD softwares don't really allow the size, like the mesh size, the higher mesh sizes. But apparently like Ansys allowed it. And then so just that, and then like adding small features. Like sometimes we don't even model like welds in a CAD software, but it's like, oh yeah, we can easily model a weld in Space Claim, and I wouldn't really do it. And from like small stuff like extracting, volumes, that's like it's like takes less than 2 seconds to extract a volume. Like we have completely stopped doing like 3-4 CAD steps in our and original CAD software. We just do it directly in Space Claim, and like, yeah, that's way too easy to do in Space Claim than any other software.
I love how like you almost feel guilty that it's too easy.
Exactly. It should be more painful. It should be more painful sometimes. Yeah.
Yeah, that transition from design modeler to space claim is usually once you realize that the tree has been holding you back as far as manipulating stuff. It's always a pretty kind of massive speed up that you can see. So always interesting to hear what people are manipulating there.
For sure. How about you, Chris? What's your favorite feature there on the Ansys side of things?
Yeah, Nitin is much more intimate with the features that it uses there. But no, he's shown me exactly what he was talking about, how to extract the volumes. That was a very interesting one that we used recently. Yeah, I mainly come over and check out Nitin's great work when he finds something cool.
Yeah, that's a really good question to ask, because you're almost the customer of the simulation, right? So do you find that the way you get information from Ansys is useful to the whole design team and design process? Is there things you like about what you get out of Ansys, and things you'd like different?
Yeah, no, it's very useful. Yeah, I mean, one of the most recent ones we did was our cooling plate. We went through a bunch of design iterations for different flow paths, and even something as simple as setting your scale the same, so you can see an apples to apples comparison of temperature across different flow paths that you've come up with. Little things like that are extremely useful.
Yeah, that's really a good point. And cooling plates are one of those things that it seems simple, but it's not.
Yeah, and you can change minor things here and there, and you get Ansys shows the different velocities around different radiuses, or you do a fin in a different location, and you can see the velocities change, and it's all very, very powerful things.
Good. Yeah. So it does sound like you guys are driving your design with simulation. Is that, I mean, in your workflow, do you use a simulation to kind of help decide the design? Are you fixing problems as they come up, or do you wait for like a real big problem before you throw simulation at it? Where does it fit in your process?
Yeah, we 100% use it on the design side. I think it really has its place all across engineering, whether it's prototyping, initial design, and then all the way through continued engineering. If something happened in the field years down the road, if there's things that you can you get that feedback, and you always want to try to close the loop, and the simulation is definitely helps us do that.
Good. That's good to hear. So one of the questions I like to ask, and this is to either of you, but probably Nitin, because you're using it every day in, day out, is Ansys developers do listen to this podcast. So if there was one feature or capability you'd like to add to the Ansys suite, what would that feature or capability be?
One thing which I really liked was, I don't know how much this has to do with how the computation is happening, but so we did use like discovery. For instance, discovery in the early stages of discovery. And I like the feature that discovery is able to use a wider range of graphic cards for processing. Now I know that Ansys in general does not like to use graphic cards for the parallel processing and stuff, but Discovery was able to. So that's something, it's always like a thing for Ansys, is like, oh, it needs those bulky, systems to run all these simulations on. But just to be able to widen the scope, just to be able to access like a lot of other people, everybody should be, so like we have 8 licenses over here, right? But and we have 8 in our team, but not everybody is using it per se.
Right.
So it's one of those things, that if it becomes more accessible, if it's not such a scaredy factor to everybody, oh hey, this is like a world which we don't really want to go in, kind of, it's just, I feel, on a wider range. I don't think it's a feature I've said, but it's just,
No,
I think it's
it's,
on a wider.
yeah, and I do think they're working on that. I know that they're working on supporting other GPUs besides the NVIDIA family, and also just making it in more solvers. So stay tuned for that. That is a good one, because it's a lot of horsepower that's sitting there on your CPU, on your computer, that you want to use. I definitely agree with that. Yeah, the next thing I'd really like to hear from you guys is and you kind of touched on this a little bit, but maybe going more in depth, is a story of how you've used simulation to really make a difference in your product. I know the last time I met with your senior management, they were really, really happy about some of the solutions that they got out of Ansys to help get their product to market faster, but their business people, so they weren't really clear on what it was. So I wanted to ask you guys, how has it really helped you get to market faster or better and things like that? Any specific examples you can share?
So like in that question, I would bring up 2 products actually. So which are both, ground up. So one is obviously a battery pack in general, which we make and which we are really proud of. So a lot of stuff inside the battery pack, like all the structure itself, bus bars, cooling plates, all of those we have simulated, all of those and everything around those. So that really helped us. So in like situations now where EV market, especially in this this whole domain of repowering, it's not really defined yet. So we don't really find information out there existing. So you don't really want to just crash a battery pack, just drop a battery pack, and just mess with your $30,000-$40,000. No, you want to simulate it first to see what will happen, what potentially will happen. So those kind of things, we were able to address before they even happened. A lot of structural things which was, and then a lot of, and cooling plates, we know like how will the modules react in what temperature. So we were able to predict, even though we are in Arizona, we were able to predict what will happen them in like Michigan or something, cold. So we were able to design for all the environments. We don't really have to put them like it should be like, and we are in a process of doing that, but we can show simulations which are like pretty good, so that we are able to put the product out in the market and not wait for actually testing and going through all these labs and everything. We were able to, that's where we were able to push the product up fast. And one of the other projects which we did was the IR heater. So that was one of our like IPs which we have. I think we have 2 IPs based on that project. And it's something which we have on a pause right now, because we ended up using some OE like heaters, but that is something which we are still on the back burner. We are still developing and thinking about it, but that is something which we use like a existing technology which was always used in like your houses and stuff, infrared heaters, and thinking, hey, can we use it in like EV? What will happen if we use that in EV? And just from the concept stage, we were able to successfully implement it and run like, I guess, 4 vehicles on our heaters in less than a year. And this was all happened, and we were able to reduce its size by, I would say, like 3 times reduction in size. We were able to calculate how much flow we need, how much heat it will generate, is it enough heat for heating cabins and the battery. So all that was done in less than a year. So that's where Ansys Fluent like really helped us bring that product to the market, and it's an IP which we can.
That's a real good point, because when you're replacing that diesel engine, say, that was providing heat for the cabin, you got to replace that with an electric heat source as well as heat your batteries up. So yeah, really, I never did think about that before. Cool. Chris, anything you've got that you can think of that's a good example out there?
Yeah, I mean, Nitin touched on
Mhm.
very good examples. Yeah, I mean, even with all the mechanical structures,
Mhm.
it just helps us speed up designing so much. Like Nitin was saying, it's expensive to do destructive testing.
Mhm.
So the more we can simulate that and keep it in the computers and get good, accurate representations of how our parts behave together and how they behave on the vehicle, also, it helps us just design that much faster.
Yeah, cool. I really excited to see. I've been excited to see the things you guys have done over the very short period of time. It's been really great to watch, and whenever I get a chance to visit and see the different vehicles you're putting your systems into, and we even had you guys come. I don't know if you made it, but we had you guys come out to one of our open houses with one of your vans that you retrofit, and or I guess repower is the term you use. It was pretty cool to see that. Doug, do you have any questions before we kind of wrap it up?
Well, I was kind of curious, like about the heaters. Like, was that an intent to have, to develop, additional IP, or was that more of a side effect of that development process, to try to find like a new way to provide heat and heat, versus using the standard? I'm just kind of curious if intellectual property was the side effect rather than the goal there.
So I would say like it was like an outcome. So it was like, so initially so I don't know if you know this, but EV industry struggles finding components, struggles a
Mhm.
lot. Supply chain is the worst in EV industry, in every industry, but predominantly in EV industry. So at that point of time, and even still, we have like 3 or 4 major like heater companies out there, like EV heaters, high voltage electrical heaters. So we were like, hey, like we don't want to be restricted by those companies, or and
Gotcha.
even those companies. So we took a existing concept. I wouldn't say we necessarily developed the concept of it. The concept has been there, but it was never implemented in a dynamic or like a vehicle application. So this is the first time it was implemented in a vehicle application, and obviously like we were able to reduce the number of parts. So that whole heater, I would say, including everything, had like 25 parts total, including everything. So it was not a lot of like 25 individual parts, obviously. But like that's where we were able to control the supply chain and that was a project which we wanted to pursue further and sell the product itself as well. Like not just put it in our vehicles, but to be able to sell that to other companies as well as a heater solution for EVs.
Okay, so that was a supply chain induced creative output. So interesting. Very cool.
Yeah, that's really cool. One of the last questions I like to ask is both your engineers, any advice you would give to a new engineer getting into simulation or putting simulation into their process for the first time?
Yeah, like so I've had this even in like this company itself. So I'm like, I was a master's, but a lot of other engineers over here are like bachelors and from the same university. A lot of them are from the same university which I'm from. One thing is like I would say is like trust science. Like it really works. That's one of the things, like if you know how it works, if you know how to get it done, like learn the basics of it, like what's happening in the system. If you really learn the basics, you would, a lot of things starts making sense. And simulation world won't be like a scary world for you if you just know what's happening in the background. That's what scares them. Like a lot of these like MOOC courses online about a lot of these softwares, they start with those, like Reynolds, like average Navier-Stokes equation and other stuff. I'm like, don't worry about this. You will learn this. You don't have to solve equations when you're solving, simulations. You just have to know what it really does. So a lot of these big equations in your computation is just like, I would say, like, don't get scared of those. It's a very inviting world, I would say, and it's getting more and more and more user friendly. Like even in the past 3 years, I've seen it grow from just being, you have to input so many parameters on your own to now it kind of does a lot of it by itself. So it is getting a lot of like more user friendly, and the terms are getting more and more into, everybody is getting accustomed to the terms it uses. So that's just my advice, is like learn the basics.
Good. Very good.
Yeah, mine will echo that. I would add to just, get really good at your initial conditions, because sometimes problems seem more complicated than they need to be. And if you can break them down effectively into the information that you're really after, as soon as you're good at that, a lot of the scariness of simulation, it goes away or it's negated. But yeah, just getting really good at those initial conditions and actually answering the question that you need to answer. If you can do those two things well, simulation is your friend.
Yeah. Cool. I totally agree with that. Doug, any closing thoughts from you?
No. I forget. It's been a while since I've said this, but I feel like it's a lost art on how to create a simple model, or a representative model. I think you guys hit the nail on the head there. It's like, the first thing you should be doing isn't generating the mesh. It's asking, what am I looking for out of this? And so, yeah, it is in the scary world. You just have to, be able to see the assumptions and what you can get out of, a simple model. So, no, that's all I got.
Pretty true. Pretty true. Well, I really want to thank you guys for joining me today in this very, very short discussion. You can learn more, and I highly recommend everybody take a look at ZEVX.com, ZEVX.com. There's a video that runs in the background. If you really can't quite get your head around what they do, it's this amazing video that kind of shows the power plant in a truck, commercial truck, and it's pretty informative, and then dig around and look a little bit more. And I highly recommend that if the company you work for has a fleet of commercial vehicles and they are looking to decarbonize, to go electric, instead of going out and buying a bunch of brand new vehicles, which are really hard to find in the first place and very expensive if you can find them, take a look at doing this repowering with ZEVX technology, and you can tell your management that, well, it's all been simulated with Ansys, so it's going to work, right? So, like I said, I can't say enough good things about the company. Keep your eyes out for them, and it's not only just a great application of simulation, but they do a lot of other cool things there. So check it out. Thanks, guys.
Yeah, thank you very much. We appreciate it.
Yes.
Have a good rest of the week.
Yeah, you too. Thank you.
Bye. As you can tell, I'm a big fan. Do check out their website. That's ZEVX.com. And help Ansys by letting your company know about their products, because the more systems they sell to people like you, the more Ansys they will use and the more cool things they'll do with Ansys. So a little bit of a push for them. We really want them to succeed. They're an important part of our growing electric vehicle ecosystem here in Arizona. We don't really talk about it too much, but I'm on a couple committees with the Tech Council, Arizona Technology Council, and one of them is the Electric Vehicle and Battery Group. And we're just seeing a massive growth here. LG just announced a gigafactory or multi-gigafactory. I think that's our second gigafactory in the state. We've got a couple of recycling plants coming in. We've got a lithium processing plant. And there's just a lot going on top of the electric vehicles with Lucid. Nikola is here in town, Electromechanica. We've got a growing number of electric vehicle and battery companies, and from ZEVX is one of our favorite in that space. So hopefully we'll hear more about them as time goes by. So let's do our commercial. So for this month's commercial, I want to talk about mentoring. One of the ways that ZEVX got up to speed so fast was to leverage PADT's mentoring service. So have you ever looked at your screen after hours of trying to figure out how to do something or fix something and say to yourself, if I could just get access to an expert to help me work my way through this, I'd get to the results so much faster? Well, that is exactly what PADT's Ansys mentoring is all about. You get access to our team of experts by the hour, and they can help you one-on-one whenever you want and whatever you need. We have been offering it for over 20 years, and our customers who take advantage of this service keep coming back for more. You do not have to be one of PADT's Ansys customers. You don't have to buy Ansys from us, or located in the Southwest or even in the United States to take advantage of the service. So please reach out to us at info@padtinc.com or our support area email, which is swsupport@padtinc.com, and ask about our mentoring services. Mentoring, it's the fastest and most cost-effective way to overcome any technical challenge you face in your Ansys usage. So let's move on to news and such, and we'll start as usual with the Ansys stock. And I'm recording this on Monday, March 27th. It's 6:30 at night here in Phoenix, and I'm hungry. Maybe that's why I'm fumbling over the words so much. But anyway, it's Monday night, and the stock closed at $316.94, so almost $317. That's the highest it's been since April of last year. And it's a ways off from that all-time high of $406 a share, but it's inching its way up. I think it's about an $8 to $10 increase since the last time we talked. If we look at the last 12 months, it's up 2.6% from where it was a year ago. So it was down a little bit, then it went up in April, and then it went way down over the course of the year. Today, the S&P is down 12.6%. So 2.6% increase for Ansys, 12.6 decrease for the S&P 500. So Ansys would have been a good investment over the last 12 months, as it has been for over several decades. But anyway, it's good to see that. We'll keep our eye on it and see what the coming months bring. Took a look at the Ansys news out there. There's nothing new from Ansys or PADT for that matter on the news front. So nothing to report there, no press releases or anything from either of us. And what I do have is some cool articles I found on the Ansys blog. So my three favorites since the last time we did the podcast episode. The first is called Meeting AR/VR Market Challenges Using Dynamic Link. So I've been very interested in AR/VR because I've been going to a couple of different meetings here in Phoenix about how to apply augmented reality and virtual reality in a lot of different places. And one of the things we don't talk about enough, because I'm a hardware guy, is the hardware. And it's really hard to make affordable, highly accurate hardware that's light, the big thing that sits on your head. And it's really about making the right sensor, which is kind of on the nanoscale. So you use the tool from Ansys called Lumerical to model that. And then on the macro scale, which is basically the lenses and mirrors and all that stuff and half mirrors, which you use a ZEVX Optics Studio for that. And what Dynamic Link is the tool that connects the two, Lumerical and Optics Studio. So this article kind of explains why it's important for AR/VR and how people designing those kind of headsets are using Lumerical and Optics Studio and linking them together with Dynamic Link to really design their systems before they get into prototyping, because you can imagine making the sensor, making the assembly, it's quite expensive. So check that out. Even if you're not an optics person, I think it's we're all going to be caring about AR/VR, and it's going to be working its way into a lot of different products. So definitely check it out. Then the next article that I really liked is called Ansys Additive Simulation Joins Forces with Aconity 3D. I'm probably pronouncing that wrong, to print defect-free bike bottom lug components. So what is the bike bottom lug? It's that thing where the pedals go, the shaft of the pedals go through, and it connects all the rest of the frame to the rest of the bike. So it's kind of that one central part that's got a lot of stuff coming in and out of it. And it's perfect for 3D printing, right? In the past, it was kind of tubes welded together, but now they're 3D printing that part. And it's really hard to 3D print correctly because of all the things that go on with thermal expansion and contraction during metal 3D printing. So Ansys Additive was used to solve those problems. So it's a great real-world example of a complex part used in production for a real-world product. So definitely check that one out. And the last article I recommend is one of my favorite series that they do, and we probably should go back to doing it. We haven't done this in a while here at PADT, but this is Ansys Inc.'s pick for the top 5 features in Ansys Mechanical 2023 R1. Give it a view and see what their support staff thinks of the favorites. And I kind of agree with them. There's some I would have picked that are different. And there's some critical stuff in there that everybody needs to know about that can really change the way you do things, especially I'll give a little hint, a little bit of geometry, associativity stuff. But I don't want to have any spoilers. I want you to read it for yourself. So check that out. Top 5 features in Ansys Mechanical 2023 R1. So those are my 3 picks. On the PADT blog, we had one article. Cynthia did another ZMAX article called Using the Star Module in Ansys ZMAX Optics Studio. And the Star Module is what connects your Ansys Mechanical to ZMAX. So it's kind of like that article about numerical in Optics Studio. This is for mechanical to Optics Studio. So it's called Star Module, and she kind of explains how to use it and get your thermal deflections into your optical model. So even if you're supplying that to somebody else, to check that out. There's 2 other blog articles that I want to point out on our blog. That they're not Ansys related, but I think they're worth mentioning. The first is that on 3/14/2023 was Pi Day. And if you've been following PADT for a while, you know we always like to celebrate Pi Day because it's an excuse to eat pie and do math, which are 2 things we generally like to do. So it's called Pi Day. 3/14 is still one of PADT's favorite nerd holidays. You can check out pictures of the pies as well as a link to this year. I put our math quiz up. So if you want to see if you can get a perfect score like Molly did here at PADT, who's one of our consulting engineers on the Ansys side of things. She did get all the questions right. It was a tough one this year. She was the only one that got them all right. Do check out the math quiz in that blog article. Pi Day is still one of PADT's favorite nerd holidays, is what it's called. And then the other article that I'm going to point out is one that I wrote called Product Development Lessons Learned. Scope change is going to happen. And this is applicable to simulation. I was really focused on design projects when I wrote this, but scope change happens with simulation projects as well. So it kind of explains what scope change is, and more importantly, how to minimize it or even avoid it. And then when it does happen, how to deal with it in a great way. And it's been pretty popular, so check that out on our blog as well. That's pretty much it for articles. And let me bring up our events page on PADT's website and talk about what's coming up in the world of Ansys. So this week, this event will have happened by the time this podcast gets published. But our Flownex team is at the 8th Thermal and Fluids Engineering Conference to talk about using Flownex for thermal fluid simulation. I mean, it couldn't be a better conference for us than that one. And I think that's in Maryland, it's at the University of Maryland. So that hopefully you're at that and you ran into them. We have a webinar coming up called Structural Updates in Ansys 2023 R1, Composites, Fractures, and MAPDL and Composites and Fractures in MAPDL. So this is the Ansys core and how to do composites and fractures in that tool. So definitely check that out. And then on the 13th of April, so we're skipping ahead a month here, but this may come out. We may not have another podcast before this comes out. We will be on the 13th at Venture Madness, which is a local event here in Phoenix for the startup community. It's kind of our big party every year for startups. And then one of my favorite conferences of the year is the Space Symposium. This is the 38th annual Space Symposium at the Broadmoor in Colorado Springs. And PADT will be in the Ansys the Arizona Space Industry booth, which we are hosting with the Arizona Technology Council and the Arizona Commerce Authority. We'll be in that booth with ASU, University of Arizona, as well as a handful of small and medium-sized companies that are there with us. And we love that event. If you are at the Space Symposium, please do stop by and say hi in mid-April. And that's what we have on the agenda for now. And I think that's what we have for our podcast. So I want to thank all of you for listening once again. Please don't forget to subscribe to our newsletter where you can learn more about PADT and the things that are going on and what our customers are doing and all that. And you can do that at www.padtinc.com/opt-in. Do subscribe to this podcast if you haven't already, whatever your favorite podcasting tool is or application is, and spread the word, let other people know. And as always, don't hesitate to reach out. Thank you for joining us for the All Things Ansys podcast, episode 116. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employer. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.